Hi everyone, my name is Sigmafine. I'm a refinery mass balance engineer at Astron Energy, South Africa. This presentation is about how Astron Energy monitors its stocks and fiscal movements to support timely validated data for downstream ERP systems using Sigmafine Intelligent Movement Management System. The content of this presentation, who we are as Astron Energy, the Sigmafine journey at Astron Energy, stock balance and reconciliation, stock balance workflow and Sigmafine benefits, IMM scope and context, IMM benefits, potential next steps. Astron Energy is a leading South African supplier of petroleum products. We own and operate the country's third largest crude oil refinery in Cape Town. With a throughput of 100,000 barrels a day, we also operate a lubricant plant in Durban. We have roughly about 850 Caltex service stations. Our products that we produce include petrol, diesel, jet, fuel oil, and LPG. We roughly have about 500 direct jobs and 13,000 suppliers and contractor jobs. So this is the overview of basically the entire presentation. Basically, it's the gap analysis, and that is Astron Energy intensified as it sought to comply to SOX data quality corporate governance. Astron Energy digital transformation addressed the need to improve quality of refinery and automate the production accounting through data reconciliation solution. And then how we resolve that. This presentation provides an overview of the transformation from legacy solutions towards Sigmafine and OSIsoft solutions for managing the process data needed for supporting business processes in inventory management, external purchases, sales of feedstocks, and finished products, as well as production accounting on a daily basis. How we improve that? Astron Energy uses Sigmafine mass balance and its intelligent movement management, and that is IMM, for daily production accounting and near real-time oil movement management. The aim is to improve operations and business process through the avoidance of costly errors and identification and implementation cost reducing projects. This is our Sigmafine journey. Basically, the Stone Age, we started on the Excel sheet. That's how we used to do our mass balance. That was prior to 2013. And that was tedious exercise, too many manual entries and human errors in the process, which was deemed ineffective. And then that's why we introduced Sigmafine and implemented it, and together with Promise. That was in 2013. We started with version 4.6. Basically, Promise was just the front of Sigmafine then, which feeds Sigmafine. Those were the inputs and flow meter information, the transfers, and all that stuff. That was implemented in 2013. And then from there, because we were going to demolish or Promise, and then we started the testing and preparation for the decommissioning of Promise. That was in 2017. And then in 2018, we decommissioned Promise and installed IMM. So now, on the very same year, we upgraded to IMM and integrated that with SEP. And that basically improved volume tracking, became relatively easy to pick up stock imbalances. It reduced manual data inputs. it became easy to validate that are the product specs that are required in the VCF calculations. So basically, I'll just talk you through the mass balance journey. Sigmafine in a plant-wide mass balance, Sigmafine reconciles hydrocarbon movement within the refinery boundary, as some may say, the fence line, and that includes feed and product meters for process units, tank inventory and transfers within the refinery boundary, pipeline shipments, and receipts. All hydrocarbon streams within the refinery, except fuel gas, and that our model excludes water, steam, and sulfur plants. We monitor the refinery imbalances on a midnight to midnight basis. Basically, on Sigmafine, there are two types of reconciliation that occur on the mass balance analysis rule. That is between two or more meters, balance between a tank and a tank and a tank, or a tank and a meter, and a node. So in order for us to track that, we use the primary metric DX1, that is the measure of the amount of correction required to close the balance. And then that is calculated, obviously, by Sigmafine. And basically, our target is we try to keep the overall imbalance below 5%. Sigmafine data reconciliation. Currently, all real-time process information, such as flow rates, levels, captured by Pi, but we don't know how accurate that information is. Then Sigmafine helps to validate this information. Then the corrected Pi data is fed to Sigmafine model, which will point out all the gross errors. It is then the job of the mass balance engineer, that is myself, to eradicate all these gross errors before a good set of reconciled results can be published for everyone to use. Errors can include anything from a noisy or a sticky gauge, sticky tank gauge, a bad flow meter, or a temperature indicator. That could cause bad temperature adjustments, bad transfer data, and et cetera, et cetera. Basically, on the far right, on the right, we have our model, and then Sigmafine model, and then our raw data, and then we reconcile that information. And then if the gross error exists, and then we try to pinpoint or eliminate those gross errors. And if all goes well, and then we have our reconciled data that we write back to Pi. So the data quality, on the data quality perspective, Sigmafine mass balance helps to reconcile flow meter raw values. The DX1 is the primary performance indicator used. The target, like I mentioned, is 5%. But with the aid of Sigmafine Advanced Diagnosis add-in, which is the ADA, improving the measurement data quality has improved so that the internal DX1 target been lowered to on an average of 3%. And as you can see on the graph, we have our 2019 data. That is the DX1 monthly average. You see, we try to keep it on average of 3%, but the benchmark is 5%. And then now moving to IMM, which is the Intelligent Movement Management. Sigmafine IMM functions. IMM is mainly used for the following: tank monitoring information system, that is TMS, Sigmafine transfer input creation for mass balance case execution, transfer tracking near real time, and historization of oil movements. So basically, if we break down these primary functions, we have our TMS, which is a tank monitoring system. We then use that for movement status monitoring, tank property monitoring, tank volume, and delta stock calculator. And then the Sigmafine inputs, and then that is transfer creation. And then we close those active transfer, which IMM automatically does that at the end of each day, that is at midnight. And then we feed those into Sigmafine. And then oil movement database, which is for safe condition monitoring, which basically means like if a tank is moving and there's no declared movement, then one will raise a call as to find out what's going on and all that information. And then the delta daily stock balancing, which is what happened on a particular day. And then for audit purposes, the nice thing about this database is that the information is there and you can call that information up, say if we have auditors a year later or annual auditing, the guys will come around and ask certain questions about certain volumes or a specific movement, and then it's easy to just filter down and then go to exactly what happened on that specific movement on that particular day. The summary, which is stock balance issues. So basically, these are basically the issues and that we had and how we resolved them with IMM. Because initially there were no warning of potential high month-end mass balance errors. So the solution with IMM, tank monitoring system, and set inconsistency conditional warnings. So basically, we try to resolve those errors. We catch those errors more like in real time instead of waiting when you have to close our stock balance at month end. So on the daily, we can see what's happening. Why is this movement going and it's not declared and all that stuff. And then the other issue that we had was a monthly delay of monthly stock imbalances. So basically, what we now do is with IMM we manage to have a daily overview of potential stock imbalances. And then undetected error in measurement, and that can be a level indicator that is faulty, or temperature point that is faulty. Basically, these are the primary inputs that we use for volume calculations. So if there's a problem with the TI point, we'll get an error of we can't get that specific volume, and then we can easily say, okay, hey, there's a problem with this, and then we send the guys to verify that information if it's correct or fix whatever that is broken. And then, so this is basically the workflow, IMM workflow. This is like who does what at what stage of a transfer. So basically, we have our planners. That is our oils planners, the schedulers. We have so these guys plan a movement as per plan. And then that information filters down to operations lead. And then that guy will then approve a transfer or rejects a transfer. It depends on the practicality of that transfer outside in the field. And then if that information is, if they agree with the planner, and then they'll approve that information, and then that will filter down to the DCS operator, who will then start and stop a movement. And then that will be me, the mass balance engineer, who will then validate all the closed movements. So basically, these are the responsibilities of each one. So the planners will input their daily movements, and then the operations lead will approve or reject a movement. And then the DCS operator will start and close approved movements. And then the mass balance engineer will validate the closed movements. So the benefits of this workflow, it's for data accuracy because there's this interdepartment connectivity. There's not one person that checks this information. So like, for instance, a planner might make a mistake and they require X amount of volume to be transferred or pumped out or whatever the case may be. And then the operations lead will say, no, hey, we have this issue here. This is not practically possible outside. These are the limitations that we have. And then when they are in sync, the TCS operator will say, hey, but you can't do this or you can do that. So, and then after that transfer is closed, I then come through to validate that information and say, okay, this is the information, it's correct, and I agree with it, and then validate that movement. And also, this also improved the personal integrity in these departments, because now you know as a person that if you don't do or you don't action this, someone is also waiting beneath you and all that. So yeah, that's that's the other benefit about it. And also here we have our oil movement database use and structure. So basically our IMM, we like I mentioned before, basically we use it for three things: daily stock balance, Sigmafine inputs for all our daily movements, and then for audit trail. So if you can just see on the snip, those are all the validated movement, like a snip of the second month, the start time, the end time, the mass in kilograms, and the material. You can always filter that, or you want to see, was it crude, was it diesel, was it jet? Right. So basically, this is just the IMM display features. All tanks properties are monitored, and display is fully customizable based on user preference. Basically, you can choose what you want to monitor on the screen, and then you can configure that from System Explorer or whatever. And then, like for instance, if you want to see density, if you want to see Carl Fisher or Paw Point, whatever the case may be, it's up to you. So, and also the tank monitoring, this helps with the tracking of fiscal movements in real time. And that includes the transfer planning, the monitoring of that transfer, the tank movement status, the product quality monitoring. Like, for instance, if you look at density, you will know you want that density to be this, and then this is the captured density at the lab, and then you'll start asking questions and all that information. So basically, you will have these sorted columns at the top, and you can choose what you want to see first on the far right and all that information. And also, if you can see there, this, if I open up IMM, I will have this view as to what happens, or the 10 that are changing, that have errors and all that information, so that I can make the necessary calls. Like, for instance, if you see all these tanks that are red, they have change in them. There is a delta, the delta volume rate, but there is no declared movement. So that means, obviously, on the workflow we discussed, someone didn't plan it. It's not in the system, hence this. So then I'll ask questions on that specific tank. Like, for instance, on the first row, there's like 478 tubes an hour. What's happening? There's a positive delta in that tank, but there's no movement. And that can be from a safety point of view now. You can't be moving something and then you didn't declare it. So that means that there's a problem, or there's a system disconnect. And also at the bottom there, we have the consistent tanks, which means you can see they are checked and there are no red warnings, which means everything is correct. There's a declared movement and it's moving the way it's supposed to be, or there's no declared movement and it's not moving. So basically, these are the conditions that must align. Now we move to the stock balance workflow. So basically, we have our oil movement daily validation, and those are imports, exports, and internal movements. And then we create a monthly tank inventory case and publish that to the SQL server. And then that moves over to oil accounting, which will retrieve the published information together with the opening, closing inventory, and all other tank properties that they require. And then, so the oil movement on the first one, it happens on the daily on IMM. And then the creation of a monthly tank inventory that we publish on SQL, we use the SQL access. That happens at month end, and then that goes over to the oil accounting, or the production accounting, as some may say. And it happens at SEP, and then that happens at month end. The daily stock balance. This is just how the information filters down. So basically, if you this part here, if I may go back a bit here, if you have the stock balance workflow at month end, this happens at month end. This poses a risk of having information that might have happened mid-month and no one knows, or at the beginning of the month. And then it's very, very difficult to close a month end if you look at a full month data. So now what we've done, we're like, okay, let's just break it down to a daily view. So what we have previously, we have a full month, you reconcile everything, imports, exports, all your 10 closing inventories and all that stuff. So now we're like, okay, let's try to scale it down on the daily. So what we'll do then, we'll take the daily closing inventories, which are provided by Sigmafine. Those the corrected net volumes, opening, closing, and then we'll have our transfers from IMM, which will be imports, exports, and all internal movements. And then we'll have stock balance by products, and then we will use Excel reports month to date. So basically, if the date is the second, we know we don't have imbalances up until the second. And then on the 15th day of the month, we know everything balances up until that day, so that at month end we don't have these imbalances by product, so it becomes relatively easy to close off that balance of a full month. And then which also helps the production accounting guys to have less time to report, and because those guys, they work on very tight deadlines. Right. And then the Sigmafine data consumers, which is now the reconciled data, the oil movements that feeds into Sigmafine, and then we reconcile that information. We'll have our value chain and optimization guys that they will use for trying to optimize their plans. And then we'll have our oils planning teams, which will be your schedulers, your planners, and then we'll have our operations, which they monitor this information. They check if it's correct. They start movements, stop movements. And then we'll have our reliability and maintenance guys, which will say, okay, this flow meter is slightly overreading or underreading. Can you please check it out and all that stuff? And then we'll have the finance guys, which is the production accounting, the process engineering, which they will take our reconciled volumes to do their daily routines, to monitor their KPIs and all that information. And also the environmental, which is for government reporting purposes. So basically, these are our data consumers of Sigmafine across the organization. And then in summary, Astron Energy has transformed its data into a digital asset through its Sigmafine journey. And from here, really, the possibilities are endless. We can see what you can do next, because at this point in time, everything is still okay. And then we have our stock balance process that became more efficient, because we used to take a lot of time in closing our stock balances at month end. So relatively now, everything flows seamlessly. And then in the process of the Stone Age stuff, we had so many redundant processes that have been eliminated, and thus giving us more time to focus what matters. And then we have improved our volume tracking on a daily basis, which then about like 80% of manual inputs have been automated, hence reducing our human errors. Because some guys, this guy will have his own spreadsheet. Also there's some duplication of information. One guy and the other guy is doing the same thing, where now we have everything all at one place. Next steps, we are still considering IMM transfer calculation plugin, basically for alarming, which have listening capabilities surrounding measurements to deduce delta stock. So it's still in the exploration stages as to how can it help us, and because it happens on version 4.7. So for us to do this, we still have to upgrade our Sigmafine version to 4.7, and then we will see now if you want the plugin and all that stuff. And then the other thing that we want to do is basically to break down our Sigmafine model into single unit models. Basically, what we'll do, the mass balance engineer has a refinery-wide information. So now if we break that down, like for instance, the platformer has its own model, and then that model is handed over to a unit engineer. And then we have our diesel plant, that model is given to a diesel engineer. So now this will make Sigmafine information more digestible to process engineers because they can now plan, they can now view their KPIs and for loop-back purposes. Because now the guy will say, how did I perform yesterday and all that stuff. And because they also do their daily mass balance, they also consider some things that we don't consider in the refinery wide balance. It's basically breaking it down to the minute details now so that everyone has their own view in their own unit, and then they can reconcile their data. And then if we agree, then they can publish that information and write it back to PI for everyone else to use. Thank you for your time.